Now the pH test. So this question is basically similar to that. Now the pH test. So this question is basically similar to that of the temperature question. What we're trying to do is find the ideal pH for catechol oxidase. So our hypothesis is that the pH, we believe that the average pH of catechol oxidase is about 7. So if we changed it to go above or below 7, then the enzyme will denature and no longer function. Now for the procedure, we obtain several test tubes and label them 1 through 7. And again, you add 1 milliliter of catechol oxidase. Then you add 1 milliliter of the specified pH buffer to each test tube. Wait 10 minutes for the enzyme to react to the pH buffer. Then you add your 1 milliliter of catechol and observe your results. And we use the same scale again to determine which was the most reactive, which is the least, and which one's in the middle. And according to this, we placed test tube 1 with pH 4, 2 with 6, 3 with 7, 4 with 8, 5 with 10, 6 with 12, and 7 with 2. Okay, so here in this video, I'm adding the 1 milliliter of catechol to the test tubes after the enzyme has reacted to the pH buffer. So as I add the 1 milliliter, there's not a gradual change yet, but over time you see the enzymes react and then they turn a specific color, and that's usually the yellowish brown. And yeah, so at the end we see the reaction and will then lead to the results. Now, coming back again to my pretty labels of test tubes, we can see the reactions of the 7 test tubes, except for number 7 because we couldn't get it in time, but that's besides the point. You can kind of see that there's a lot of reaction based on pH. So what we did is we thought that the pH of 4 had the pH of 6, which is test tube number 2, had the greatest depth of brown there is compared to all the other test tubes. So basing it off of that, we were able to determine which one was the next, was like under and then under. So what we got was that test tube 2, which pH of 6 was the highest result. Then the pH of 4 and 7 were the next. Then pH of 2. And then all the basic pHs were 0. So from this, we were able to determine that this enzyme, catechol oxidase, is able to function in rather acidic environments, like not really high acidity like 1 or like 2, but more around 6 or 7. So yeah, another pretty graph here. As you can see, test tube number 2 had the highest rate of reaction, so it's at number 3 because it was the most brown. Test tubes 2 and 3 were the second brownest because they had the pHs of 4 and 7. And then test tube number 7 had a pH of 2, which is rather acidic, which is an environment that catechol oxidase can function in. However, in test tubes 4 through 6, they were basic, which means that an acidic enzyme will not function. So finally, to the last conclusion, we go back to the question of what is the optimal pH or ideal pH of catechol oxidase. And so based on our results, we were able to conclude that the optimal pH is 6. And seeing that it is under 7, which is neutral, that means it is rather acidic. So it can perform functions under acidic environments rather than basic, like test tubes 4 through 6.